All right, let's do problem number 5 on the Unit 5, the practice final that I gave you. And here's what's given. Here's number 5. Right here it says, a football is kicked from the ground with an initial velocity of 35 meters per second at an angle of 40 degrees. How much time will it take before the ball hits the ground? What horizontal distance will the ball travel? What will be the maximum height of the ball? Very typical kickoff kind of problem. So here I've already written it up. We've got an initial velocity of 35 meters per second. It's going to go up and down, and it's going to land at the same height it was kicked from. So we want to know how much time is that going to take? How far is that? What's our delta x? And then what's our maximum height, which is right in the middle here. What's our maximum height? All right, so let's solve it. Let's do A. Well, the time right here, what do I know? The time it takes when it goes up and down, we know that delta y right here is equal to 0. Because it's at the same height it started from, right? So delta y equals 0. Now, I didn't tell you that delta y equals 0 right there. You have to know it. Well, if delta y equals 0, and I'm trying to find time, so now I look at my 3 kinematic equations. And I only look at them in the y direction, because the x direction has no acceleration. But I know what the acceleration in the y direction is. It's negative 9.8 meters per second squared. Okay. Now, I didn't tell you that in the problem, but you need to know that that is the acceleration in the y direction. So, what do I not know? I don't know I know the initial velocity because I can fit, but I don't know the final velocity. So which equation doesn't have the final velocity in it? The third kinematic equation. So delta y equals v naught y times time plus 1/2 a t squared. This has time in it, it has delta y in it, it has v naught y in it, it has the acceleration. I know everything except for time. Now this is equal to 0. And the nice thing about this being equal to 0 is that I don't have to use the quadratic formula to solve for time. If delta y was not equal to 0, I could still solve for time, but I would need to use the quadratic formula. Because the fact that all of this is equal to 0 means that I can divide both sides by time. Right? You can divide everything by time. And it's still equal. It's algebraically allowed. So that means time cancels out, time cancels the time squared, and this is still equal to 0. So now I have v naught y equals, v naught y plus 1/2 a times t, because that's what's left over, equals 0. And now I'm going to solve for time in one step. I'm going to put this on the other side, so that's negative v naught y. So I subtracted that over. Then I'm going to multiply times 2, and then I'm going to divide by a. And that gives me my expression for time. Everybody follow along? Then I can plug in my values. Well, v naught y, well, what is that? That's 35 meters per second times the sine of 40 degrees. Right? That's this. So here's v naught. It has an x component and a y component. Very important that you break that initial velocity into its x and y components. Then you have to multiply that times 2, and then you have to divide it by the acceleration in the y direction, which is negative 9.8 meters per second squared. And now, oh shoot. Did anybody find my calculator with the green? Anybody have that calculator? Then I'll have to use my calculator here on my phone. So I got 35 times the sine. Oh, and this probably, yeah. 35 times 40, then I got to hit sine equals, then times 2 equals, divided by 9.8 equals, and I got 4.59. Is that what you got? Those of you who did this problem? Did you get 4.59 seconds? Did anybody do this problem? Yeah, that explains a lot. All right, and then part B, what is delta x max? Well, we have one kinematic equation in the x direction. There's no acceleration in the x direction. So the third kinematic equation just reduces to v naught x times t. You might want to put plus 1/2 ax t squared on there, but that's a silly thing to do because the acceleration is 0, so this term just goes away. So this is all I've got. Yes? Yeah. Oh, thank you. Let me zoom out. Yep, I'm ever off screen when I'm recording, just let me know. All right, so so now I can figure out what delta x is. Well, what's v naught x? Well, it's 35 meters per second, but what do I have to do to it to get the x component?
Cosine data.
Is it sine or cosine?
Cosine.
It's cosine because it's adjacent, right? So cosine 40 degrees. And then I'm forced to use the time 4.59 seconds. And so let's do that. And so I'm going to go 35 times, and then I go 40, and then I hit cosine equals, and I get 26.81, and then I have to multiply that by 4.59, and I got 123. Woo! I don't think this is a realistic problem. That's like, yeah, this was kicked by a robot or something, and the ball is probably punctured and shredded, because that's what's a good kickoff is usually about like 60 yards or something.
Yeah.
But this one is, I think Arnold did this. Arnold Schwarzenegger did that one. All right. And then part C. We want to know what is delta y max. A couple different ways of doing it. At the very top, the velocity in the y direction is equal to 0. Now, I didn't tell you that, but you need to know it. I didn't state that in what was given, but you need to know it. And so now we can do, I can use the second kinematic equation, or actually I could use the fourth. I'm going to use the fourth kinematic equation because I don't know what time is. And, well, I mean, I do know what time is, but I don't want to use it because what if I made a mistake? So if you have v squared equals v naught squared plus 2a delta y. Of course, these are all in the y direction only. And so I know that this is 0 when I'm halfway through. And so now I can solve for delta y. I'm going to do that in one step. It's negative v naught y squared over 2a. Now I can plug in my values. Negative, and this negative doesn't get squared away by this. Well, that's going to be 35 meters per second times the sine of 40 degrees. That's v naught y. Then I got to remember to square it, and then divide it by 2, and then divide it by negative 9.8 meters per second squared, because that's my acceleration in the y direction. And when I do the arithmetic, let's see, follow along with me. I'm going to go 35 times 40 sine equals, and then I'm going to square that. I get 506, and then I'm going to divide that by 2, and then I'm going to divide that by 9.8. and I get 25.82 or 25.8 meters. And that's my answer for C. Now there's another way of doing it. I could use the second kinematic equation, which says that delta y equals v naught y plus vy divided by 2 times time. But here's the thing. At what time is the velocity equal to 0 in the y direction up here? Well, it goes up and then it comes down. So it's only half the time. It takes half the total time to get to the maximum height. So v naught y, that's 35 meters per second times the sine of 40 degrees plus 0, because up here v naught y is 0, divided by 2, and then I have to take the time, which I calculated to be 4.59 seconds, but I have to divide it by 2 because it's happening halfway there. So, so let's try it again. We've got 35 times the sine times 40 sine equals, and then I'm going to divide that by 2 equals, then I'm going to multiply that times 4.59 equals, and then divide that by 2, and I get 25.8. Woohoo! So I did it twice and I got the same answer. Did it 2 different ways, got the same answer. Now what does that mean? Well, that means that my time is correct. Because if my time was wrong, I wouldn't have gotten the same answer. As part C. You don't have to do it 2 ways like I just did. On the test, you probably won't have time. But if you did have time, what if you're working and there's 10 minutes left and you want to check your work? Do this a second way, and then if you get the same answer, you go, all right, I'm doing well. Any questions?
How long will we have for the final?
About 2 hours.
Oh, okay.
I mean, you get pretty much the whole time. Okay, that is all.